reporting p-values, it's not always a good idea to sort of report them in full. So for example, if you've got non-significant p-values, don't give all the decimal points, just put non-significant. Values that I would say are significant but not highly significant, probably best to give them to 2 decimal places. So if these were the exact p-values you got from your package, then abbreviate them. The only exception where I'd use 3 is if you've got something that's borderline significant, and if you summarise that as 0.05, people would think that was significant, whereas it wasn't quite significant. So I'd maybe just add an extra significant figure. For other significant results, then I wouldn't put the detail in, I'd just give one significant figure so people can clearly see what level of significance you've got. For very highly significant results, as I said, I never like saying the value is exactly 0 because it's never exactly 0. Say it's smaller than a very small value, and typically people don't go much lower than 0.0001, or if you do, give it as a 10 to the minus a power. However, this is what I do. There's no strict rules, but I think it's, try and be neat in presenting your p-values. Don't give lots of significant figures. It's just to mention that historically, when people they didn't have packages, they would have to do their tests by hand, and then they would have to get their p-values by looking up their test statistic in a relevant table for their distribution. So here the null distribution is the t distribution. They would get an approximate p-value from this table, and they would usually just summarise it as, well, p is less than 0.05, or it's greater than 0.05, it's not significant, or it's significant but not less than 0.01, or it's in this band. And these would be the descriptions between sort of significant and very highly significant. And the convention became to sort of give stars depending on how significant a result is. So if it was just significant, you'd get 1 star, and then highly significant, less than 0.01 but not less than 0.001, you'd give it 2 stars. For p-values which were very small, less than 0.001, you would get 3 stars. And people still use that a lot today, and the understanding has just stayed with, I think, the scientific community. They'll put stars on diagrams, stars on tables, and I suppose it does make it quite easy to see how significant a result is, but there's no particular reason to use it other than it's just become a convention. A few notes on reporting results. You can either do it descriptively or in table form. You might give a mean difference along with its standard error and the p-value in abbreviated form. Or you could give a confidence interval. Sometimes people find that easier to sort of think about than a standard error. Or instead of giving the exact p-value, you could do what I mentioned just now and put stars on it, which makes it easy to pick out which results were going to be significant. This is just a comment to say that if you've got a confidence interval for a difference that doesn't overlap 0, then it's going to be equivalent to having a significant value at the 5% level. So these are examples of various confidence intervals for differences, and the ones that don't overlap 0 are going to be equivalent to a significant difference between those groups. And that one does overlap 0, it's not significant, and even if your confidence interval's negative, if it doesn't overlap 0, you'll find if you do a statistical test, a t-test, it'll be significant.